So now let's say we have arithmetic progression series given us, let's say -2, let's say a 0, dot 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 in this case. Let's say up to, that should be negative, should be 200. Let's say this is the case. So what is the number of terms in this actually particular arithmetic progression series from the first term up to this as the last term? So in this case we have the first term given as the -2, and what is the common difference? We have it as 0 minus 2, and that will be given as should be 2. And we have the nth term, which is the last term. We have it as 200. So how should you be able to have the number of terms if this is the case? So now again, to use the actually nth term formula, we should be given as nth term is equal to the first term n minus 1 times the common difference. In that case, we have 200 as the last term. The first term -2 plus n we don't know minus 1 times the common difference, which is times 2. We'll have 200 is equal to -2 and plus 2n minus 2, and of which we can have it as in this case. Now we'll have it as 200 is equal to -4 plus 2n. That will be given as 200 plus 4, that which is equal to 2n. Now that will be given as, let's see, in that way we'll have it as, now 204 is equal to 2n. That is the same as n is equal to 204 divided by 2. That will be given as 202. So which means we have the number of terms given as 204. So which means actually 200 and actually a second term should be 202nd term. Okay, should be in this way. You should have to interpret in this way. So which means, as it stands here, it means should be 102 should be 102nd term is equal to 200. That's how you can also have to get it up to. So which means actually a term number 102 is that of 200. So bear that in mind. Let's say have arithmetic progression series given us, let's say negative half, let's say -5 over, let's say 7, and let's say we have, in this case, on the up to, let's say negative, let's say we should have it as -4 over, let's say 20,000. Let's say this is the case. So what is the number of terms corresponding to this actual particular arithmetic progression series? Much as this is the first term, we'll have the common difference, and this is the actually the last term. You can have to have that out at your own time. Now what if we are sure that the sum of, let's say we have this case, we have, let's say, arithmetic progression series given us -5, -2, now in this case let's say up to 500. This should be, now in this case, now say it should be in this way. Let's say we do not have the last term there. So what is the number of terms if the summation of, let's say it should be this way. So what is the number of terms for the sum of, let's say, 6,000? Let's say we have the summation of n terms. It should be summation of n terms given as 6,000. What is the number of terms corresponding to a sum of 60,000? Actually 6,000. So we have the first term given as -5. What is the common difference? -2 minus -5. That would be given as 3. So which means the formula will be given as summation of n terms. We'll have it as n over 2 times 2a plus n minus 1 times the common difference, and of which we'll have a 60 times. We'll have the 60 times. So 6,000 as the summation. N over 2, we don't know the number of terms. That's what we're looking for. We have the first term as just the common difference. We'll be able to have the number of terms in that order. So try to have that out. So that's how we find the number of terms using the nth term formula as well as the sum of terms formula. So thank you.